Hi everyone, and welcome to the first video on C++ and lists. So at this point in the course, all of you are comfortable with creating a single variable in which to store a single value. So if you want if you want to average three different values, you can create one variable for each of those three values. In this video, we're going to expand that though and allow you to actually save lists in C++. So instead of saving a single value, you save a list of values. So before we do that, let me give you some motivational examples. Suppose you are writing a Hangman program, and one of the features that you want to incorporate is whenever the user wants it, you can tell them what letters they have previously guessed. So the user has guessed the letters A, S, and T, and they ask you, hey program, what letters have I guessed so far? And you output those three letters to the screen. If you want to do that in an efficient way, it seems like the best thing to do is to have a running list going, and that list just saves letters that they have guessed as they come. So if they've already guessed A, S, and T, and then the next letter they guess is an R, then you would throw that R into the list also. So it seems like the best thing to do is to have a running list that can grow as the user guesses more things, and then output the values of that list to the screen when the user wants to. So before I give you another example, you might tell me that, well look, in this example you've given me, I don't think I need a list necessarily because there are only 26 letters. So why don't I just declare 26 different character variables, one for each letter, and as the user guesses, just start storing those guesses in the variables, the 26 character variables. I mean, 26 isn't that many if you think about it, right? So I would say to you, well, that's not a bad objection for this particular example, right? You can get away without having a list in this example, just having 26 separate character variables. But here's another example. Suppose you're selling books, right? So you're Amazon.com or you're Barnes & Noble. You want to keep track of all the prices of all of your books. You could have a different price variable for each book. So in your code, you would have a long list of variables like this. This first variable would be for your first book. This second variable would be for your second book, and so on. But of course, if you are Barnes & Noble or Amazon.com, you have hundreds of thousands, if not millions, of books to keep track of. So you don't want to create 2 million different variables, right? That's not practical at all. What you'd like is just to create a list and store the values in that list as individual entries inside that list. C++ lets you do that, so you can store a list of data in a single variable rather than creating millions of individual variables. So without this feature, computer programming in the real world would be impossible. So in the little toy programs we have written so far, you are able to get away without having a list, right? But if you are actually a programmer for a company, for an engineering firm, whatever, you have to have a way of just having a list of data and not just having a bunch of individual variables floating around. C++ has two different kinds of lists. They have C++ has vectors and arrays. In this video, we were only going to talk about vectors, and in subsequent videos, we will talk about arrays. So we're going to use them for two different purposes. We're going to use vectors for one-dimensional lists. These are lists that you generally think of as lists. Okay, so when you picture a list in your head, you picture a one-dimensional list, right? It goes from left to right. There's only one row here, right? You just list all your data out from left to right. You can think about having lists in higher dimensions though. So here's a two-dimensional list. There are both rows and columns here. This is a matrix if you like, right? A 2x3 matrix. You could also think about having three-dimensional lists or four-dimensional lists or whatever. Anything that's above one dimension, we're going to use arrays to model those. So just for example, imagine that you want to model the motion of a particle on a cube, all right, in 3 space. So the particle is moving throughout the cube, and on the boundary of the cube, you would use a three-dimensional array to model that motion, to model positions. You wouldn't necessarily use a vector. Vectors are better for just normal lists, right, what you normally think of as a list. Arrays are better for two-dimensional and higher lists. Okay, so now let's talk about vectors specifically. If you want to use them, the first thing you should know is that you must do this at the top of your code, or nothing will happen when you use them. The code will not compile. To declare a vector, you have to tell the computer four things. First, you tell the computer, I'm declaring a vector. Then, inside of these less than, greater than bracket symbols, you tell it what kind of data you're going to save in the vector. So tell it what the entries are. So you would type something like int in here if you're saving a list of integers. You would type float if you're saving a list of decimals, etc. You then tell it whatever name you want, right? Call it whatever you want, and then tell it how many entries there are. So those are the four things that you can tell C++ when you declare this. Tell it it's a vector, so I'm declaring a list. Tell it what the entries are, right, or what type of entries you have. Give it a name, and then give it a size if you want to. So if you want to create a list of 10 integers, here is the code that will do that for you, that will declare that for you. So I'm creating a list, I'm creating a vector, and the entries are going to be integer type. Here is my name, my vector, and here is the size. I'm going to have 10 entries inside of that list. One thing you should know is that you actually don't have to hand a size here. When you declare your vector, you don't have to give it a size. What will happen is that the computer will create an empty list. So you might think that an empty list has no value, but vectors you can change. They're dynamic. You can add entries to them or take entries away. So sometimes it's helpful to just start with an empty list and then add stuff to it later as you need to. So in any case, you don't have to have a size here when you start. Okay, before we look at some code of this, here are a couple of things to point out. A vector is a list, okay, and excuse me, lists have entries, right? There's a first entry, a second entry, a third entry, and so on. Like strings, the entry at position in the first position is actually at position 0. So C++ always starts counting at 0. This is probably obnoxious to you, but that's the way it is. Okay, so if you're trying to access individual entries of the vector, you should be aware that the first entry is at position 0, not at position 1. Okay, if you want to get your hands on individual entries of a list, you use the square bracket notation that you used for strings. So whatever the name of your vector is, if you now do bracket I, it will return the entry of the list at position I. So myvec bracket 0 is the entry in the first position. So hopefully all of this reminds you of strings. So you've seen things like this before. If you want to think of it that way, a string is a vector. It's a list of characters, right? If I have the string hi there, that's a list of 8 characters, right? Hi space and then THERE. Right? So strings themselves are vectors. Okay, so now let's actually go to some code and look at this. So notice I have this hashtag include vector up here. So now let me declare a vector. Let's make it an integer vector. Let's give it a name. You call it whatever you want, right? And let's say it has size 4. So right now I have a list of size 4, but the 4 entries are empty because I haven't given them values yet, right? So this vector has an entry 0, entry 1, entry 2, entry 3 for four entries, but none of them have values yet. So let me just give them some values. So let's say that why did it autocorrect that? Okay, so maybe you want the first entry to be 1, maybe you want the second entry to be, I don't know, 7, the next entry to be whatever, -1, oops, I have to tell it the position, right? And then the next entry to be 14, whatever, right? Now we have a list with values for each entry. So this is now literally the list 1, 7, -1, 14. That's the list of values you have now inside of myvec. Okay. So now if I ask the computer, hey, tell me tell me what is in position 2, right? It will tell me. it will tell me that in position 2, which is actually the third entry, right? The value is -1. Okay, so that's what it looks like to declare a vector and to give it some values. If you ever want to know how many entries are in your vector, you use the size function, and the syntax is name of your vector dot size and then empty parentheses here. That will tell you the number of entries in the vector myvec. So for example, in this vector here, if I ask it to output myvec.size, it should of course tell me 4 because that's how many entries I have, right? And that's what it does. Notice though that this is in contrast to strings. So with strings you don't do dot size, you do dot length. Now the idea is the same, right? With a dot length you're just getting the number of characters or the number of entries inside of the string. And dot size is doing the same thing, but the terminology is different. Okay, if you ever want to print all of the entries of a vector, the easiest thing to do is use a for loop. And so what you'll do is just start at position 0 and output what's there, right? myvec at position 0, and then keep going until you're done with the vector. And you're done with the vector when you get to the position of size -1. Right? So if the size is 5, that means that the last position is 4, right? Because the counting starts at 0. So let's just make sure this does what I say it does. So we have a vector here already. So let's start at position 0. The size is 4, so we're going to go up through position 3. Oops. And let's see out these guys. So each pass through the loop, we're going to output the entry at the corresponding position. So notice that's what it does, right? It outputs that list with a new line in between each entry. Okay, so the next thing I want to do is I want to show you how to use loops to initialize these vectors or to give these vectors values. So suppose you want to save the first 200 positive even numbers into a vector. Okay, if you want to do that, let me just clear out this. Well, I suppose you could say, well, I want my vector to have 200 entries in it, right? The first 200 positive even numbers. And then you could go through and like by hand give the vector all these values, right? I suppose you could do this. I'm already tired of doing this, of course, right? I don't want to do this 200 times. So a lot of times if you want to give a vector values, so you want to actually fill in entries of the list, the easiest thing to do is to use a for loop, and I'll go up through the size. Let me just comment this out for now. Okay, so all I'm going to do is close the parentheses here. There we go. So what I'm going to do is I'm going to save the first 200 even integers into my corresponding position. So what's happening here is I have a formula for even integers, right? For even numbers. Even numbers are just 2 times 1, 2 times 2, 2 times 3, right? That's how you list all of the even numbers. So whenever you have a formula in terms of the position, which I do, just 2 times the corresponding position, the easiest thing to do is use a for loop to save all of the entries. So now let's just print this vector to the screen. Now I have to go up to 200, and let's just see what it outputs here. Some of you can probably already see that it's not going to do exactly what I want. I wanted it to print the first 200 positive even numbers, and let's see what it does. So it started with 0 and then did print a bunch of even numbers in order all the way up to 398. So it basically did what I wanted. It's just that the list is slightly off, right? I wanted it to go from 2, because 2 is the first positive even number. I wanted it to go from 2 to 400, not 0 to 398. So let me just issue the same warnings as I have before. Anytime you're dealing with loops and positions inside of a string or a vector, you need to make sure that your that your loop is running as many times as you want it to run, and that it's actually doing what you want it to do. So in this case, it ran the correct number of times. It just the list is off. It's sort of shifted down by 2. Since the list is shifted down by 2, the easiest way to correct for that is just to shift it up by 2. So now when I is 0, the entry at position 0 will be 2 times 0, right? 2 times 0, which is 0, plus 2. So now the first entry will be a 2. So now this runs from 2 until 400. Those are the first 200 positive even whole numbers. Okay, so let me issue one more warning here again. Notice that this loop goes from 0 until 199. It does not go until 200 because I is less than 200. So as soon as you hit 200, you leave. Since the size of the vector is 200, you might be tempted to write a less than or equal there, and here too, right? Let's just see what happens if I do that. Essentially what it did is now it's gone too far, right? It went from 2 to now 402. And so actually, it's sort of unpredictable what it will do here. This time, it actually created a new entry in my list, right? My list initially had size 200, and it created a new entry to sort of correspond to what I was telling it to do. So now my list has size 201. But the point of me showing this to you is that you don't want 201 entries, right? You want 200. Therefore, the count runs from 0 to 199, not from 0 to 200. So sometimes you get wonky things if you try to include a position that wasn't really there. That's what this is doing. It will either freak out at you and print out something stupid, or it will create an extra position. And you didn't really want it to do either of those things. Okay. So I want to close this video by talking about one of the most useful aspects of vectors. And what I'm about to tell you is not true of arrays. So this is an advantage of vectors over the other list type. It's an advantage over arrays. Vectors are size dynamic, which means you can change their size. And in particular, you can add entries to the back of a vector if you want to. So if you want to throw the number a onto the end of a vector and make a now the last entry, you can do that using the pushback function. So do your vector name and then push back whatever this value is. That will append that vector to the end of your, that entry to the end of your vector. So at this point in the code right here, my vector currently has, at this point right here, my vector currently consists of the first 200 positive even numbers. So now, for whatever reason, let's just say you want to throw the number 1 to the back of that. Oops, push back. So you want to make 1 the final entry. Now let's print out the list, and now the list has size 201. So let's print this guy. Notice now it prints out the first 200 positive even numbers, and then it prints out a 1 at the end. And that's because I threw a 1 onto the end. Right, so I changed the size of the vector. I gave it a new value at the end, which increased its size by 1. So you can use this function over and over again if you want to. You can take a vector of size 1 and add 30 values to it to get a vector of size 31. You can do that. You can also take entries off of the end of a vector, and that's using a popback function. And I see a typo here. You actually need empty parentheses there, but whatever. So let me show you that. So suppose that I add this 1 to the end, and then I think, well, I didn't really want to do that. I don't really want that 1 at the end anymore. Then this popback function will just take that and throw it out. So now let's run this. Okay, so somehow, since this is going up to 200, it still remembers that it's there. Okay. So let me do it like this. Let's go up to now myvec.size. So this for loop now will start at position 0 and then go up until where it's supposed to, and capital V. Okay. So now this for loop will just print whatever is in the vector. And by the way, this is the most general for loop you can use to print what's in the vector. You always want to go from position 0 up until the size of the vector minus 1. Okay, so now let's run this and see what happened. Yeah, okay, so what happened here was I started by saving the first 200 positive whole numbers. I threw 1 onto the end, and then I kicked that 1 off, and then I printed the vector. So now let's just let's do this pop back thing again, right? Why not? Oops. So let's throw something else off, and let's print the vector again and see what happens. Now notice it ends at 398, not at 400. So you threw a 1 on, then you kicked that 1 off, and then you kicked that 400 off. Okay, so maybe you want to kick 5 entries off the end of it, right? Once you start doing that, it seems like you should use a for loop to do that, so you quit having to write pop back every single time. So now let's do my vec.pop back. And now this loop will run 5 times and just kick the last 5 entries off. So here, the vector has the first 200 positive whole numbers, then I kick 5 of them off, and then I print the resulting vector. So let's look at that. Okay, now it only prints up to 390, right? So it kicked 392, 94, 96, 98, and 400 off of there because you popped the final 5 entries off. Okay, so again, you can change the size of a vector if you want to by kicking things off the end or adding things to the end. A natural question to ask is, well, what if I don't want to add entries to the end or delete entries from the end? What if I want to add entries in the middle of a vector, or delete entries from the middle of a vector? That's a more complicated question that we're not going to deal with in this video. Okay, it's a good question, and you can do it to an extent, but at the very least, it's useful to be able to throw things on the end. And let me show you why it's useful, or give you an example of why it's useful. This code here is, this code here, there we go, is a program that you've already written. What it does is it gets a number from the user and then prints the divisors of that number to the screen. So this is code that all of you have written in some form, right? This is kind of a threadbare version. There's no output to the screen, right? But I type in 14. It gives me the divisors of 14. Okay, so if you forget the logic of this, all you do is you're starting at 1, just ask, is 1 a divisor of 14? Is 2 a divisor of 14? Is 3 a divisor of 14? That's what this if statement is doing. And every time that you get a yes to that question, you print that divisor to the screen. Right, then you keep going. So if you enter 14 here, you're just going to march through the numbers 1 through 14, and every time you get a hit, you print it to the screen. Okay. Suppose now, though, that this little code segment here is part of a much larger program, a program that's thousands of lines long. What this little code does is it just prints the divisors to the screen, but as soon as you get to this brace right here, that information is lost. So you printed those numbers to the screen, and that's great, but now suppose that later in your code, you want access to those divisors again, right? Like, you want to know what the divisors of 14 were again. I suppose you could, redo this code every time you want to do that, right? But that's not efficient. The best thing to do is just to, instead of printing the divisors to the screen only, save the divisors in a list. And now you have those divisors saved for future reference. So let's just go through that and see how that would work. So I have a vector of integers, and let's call it, divisors or whatever. I'm creating a list of divisors. And now, instead of printing out to the screen, every time I get a hit, I'm just going to push back. I'm just going to throw that value onto the end of my vector. So I'm going to start by getting a hit at 1, right? 1 defines everything. So 1 is going to get put in my list. And then if I enter a 14 here, then 2 will be thrown into the list, and 7, and so on, right? So this while loop just creates the list, and now if I want to print the list, I go from position 0 up until the size minus 1. So divisors dot size, and just do it one at a time. So let's print divisors at that position, and let's put a space in between. Okay. So let's run this now. If I enter a 14, notice it prints the divisors of 14, right? So from the user's perspective, this code that I've written now is the same as this code that I started with, right? You just enter a number and you print the divisor. But the code is actually doing something much more sophisticated and, in some sense, much better. You know, if you care about remembering those divisors, the code now remembers what those divisors are, and you can access them whenever you feel like, so long as this list is there, right? This divisors list. So lists just give you a way of recording things, right? So just one other example before we quit here. Suppose that you want to compute an average. So let me just change this to numbers here. So before, if you wanted to compute average of numbers and you wanted the user to be able to enter as many as they wanted to, the code looked like this. Oops. Whoa. So the code looked like this. You had like int sum was 0, right? And you had int count was also 0, so you kept track of how many things they entered. And here, as long as they were entering a number, you did sum equals sum plus n, and you kept track of how many times they entered. And then at the end, you did, you know, the average is the sum divided by the count. Right, that's what you did. So if I run this, if I enter 1, 1, 2, and I'm done now, oops, it prints out the average of those, right? But again, this is a memory-less thing that happened here. You actually don't remember the numbers that the user gave. So if you want to remember the numbers that the user gave for future reference, you can do numbers.pushback and now throw that entry into the list. So this while loop now will just create that list, right? And so now if you want to compute the average, well, I suppose you can compute the sum like this for int I equals 0, I less than the size of the vector, so numbers.size, I plus plus. You can just say sum is sum plus the guy at the current position. So you're just adding up all of the individual entries of the list. And then at the end here, you can just take your sum and divide by the number of entries in the list, which in this case now is numbers.size. So again, the logic here is basically the same. You're just taking a bunch of numbers, adding them up, and dividing by the number of numbers, right? That hasn't changed. But what's happened here now is you remember what those numbers were. What the user gave you is now saved inside this list. So you can reference this list later if you need to. Okay, so for now, that's all I have to say about lists in C++.